SGR 1806-20 is a magnetar, a type of neutron star with a very powerful magnetic field, that was discovered in 1979 and identified as a soft gamma repeater. SGR 1806-20 is located about 42,000 light-years, 24 quintillion 600 quadrillion miles, from Earth on the far side of the Milky Way in the constellation of Sagittarius. It has a diameter of no more than 12 miles and rotates on its axis every 7.5 seconds, 19,000 miles per hour rotation speed at the equator on the surface. As of 2016, SGR 1806-20 is the most highly magnetized object ever observed, with a magnetic field of over 1 quadrillion Gauss-G, 100 billion Tesla intensity, compared to the Sun's 1 to 5 G and Earth's 0.25 to 0.65 G. 42,000 years after a starquake occurred on the surface of SGR 1806-20, the radiation from the resultant explosion reached Earth on December 27, 2004, GRBO 41227. In terms of gamma rays, the burst had an absolute magnitude of around -29. It was the brightest event known to have been sighted on this planet from an origin outside the solar system until GRBO 80319b. The magnetar released more energy in 10% of a second, 10 duodecillion joules, than the Sun releases in 150,000 years, 400 septillion watts times 48 trillion s equals 185 duodecillion joules. Such a burst is thought to be the largest explosion observed in this galaxy by humans since the SN 1604, a supernova observed by Johannes Kepler in 1604. The gamma rays struck Earth's ionosphere and created more ionization, which briefly expanded the ionosphere. The quake was equivalent to a magnitude 32 on the Richter scale. A similar blast within 10 light-years, 58 trillion 800 billion miles, of Earth would severely affect the atmosphere, by destroying the ozone layer and causing mass extinction, and be similar in effect to a 12 kiloton nuclear blast at 4.7 miles. Holy goddamn shit. The nearest known magnetar to Earth is 1E1048.15937, located 9,000 light-years, 530 quadrillion miles, away in the constellation Carina. SGR 1806-20 lies at the core of radio nebula G10.0-0.3 and is a member of an open cluster named after it, itself a component of W31, one of the largest H2 regions in the Milky Way. Cluster 1806-20 is made up of some highly unusual stars, including at least two carbon-rich Wolf-Rayet stars WC9d and WCL, two blue hypergiants, and LBV 1806-20, one of the brightest, most massive stars in the galaxy. A 2024 paper posited that periodic gamma-ray and X-ray bursts from the pulsar are caused by a planet orbiting SGR 1806-20. This SGR 1806-20b would be some kind of rocky world with a mass between 10 to 18 Earth masses with an orbital period of 398 days and a semi-major axis of 1.18 astronomical units, 167,400,000 miles. SGR 1806-20b is notable for its eccentricity of 0.994, which would make it the most eccentric exoplanet known.